Hello, my name is Mark Fulton. I'd like to welcome you here today on behalf of the analyst teams at Carbon Tracker and Energy Transition Advisors who have worked on the detailed analysis that flows into this study of the demand and supply conditions for the natural gas industry. This is the third study and what we call carbon supply cost curves. The first study was on oil, completed in May 2014. That was followed by coal in September 2014, and now we present natural gas. I would now like to take a few minutes to run through exactly what it is that we look at when we talk about carbon supply cost curves and how we believe they should be used and interpreted by both investors, corporations, and markets in general. Now, looking at slide 1, the first thing we do is to derive an unconstrained supply estimate for fossil fuels out to 2035 in this case, which is based on leading industry databases. For natural gas, we have used the Wood Mackenzie's global economic model. We then interact this supply curve with key demand scenarios. We have a low demand scenario estimated by Carbon Tracker, which tends to be lower than the IEA new policies scenario, taking a tougher view of what might occur. For the IEA 450 parts per million demand scenario, we also use a reference carbon budget based on current shares of fossil fuels in the energy mix. These two combined get us a feeling for a sustainable demand to achieve a 2-degree outcome. We show the supply curve in terms of production, how many barrels of oil, BCM, and so on, but we also show its carbon equivalent, how much that production produces in terms of gigatons of carbon. If we now move to the second slide, we will now see a stylized version of that process here. So here we have a Wood Mackenzie unconstrained supply curve for what would be close to the LNG market for gas, where we see in the low demand scenario how much is both coming from existing and under construction projects, and how much new projects might be needed to meet even our low demand scenario. If we also put upon this a carbon reference budget or a 450 parts per million demand, then you would see that we need less new projects. Now, to the right hand of the curve in the orange is what we call the unneeded new projects. These are new projects identified in the database that would not be consistent with that low demand scenario. And therefore, this is what we call the ability to produce wasted capital and stranded assets in the very long run. So you'll see that we have the cumulative production and we have the carbon content, we have a cost curve, and we have an interaction with demand, with low demand being the key focus. And this low demand scenario, we believe, is a credible scenario for the industry to look at. So if we turn to slide 3, I can sum up this notion of unneeded capex. And I think I want to introduce a concept which is useful in what we might call a demand misread. So we have our notion of a low demand scenario. The IEA has a notion of what would be consistent with a 2-degree or 450 parts per million climate outcome. For us, the low demand scenario is at least credible enough that companies should take it seriously. If we're right, and they misread that demand, thinking it's going to be higher, then they're going to start developing many of those, what we believe are unneeded projects on the right-hand side of the curve we just showed you. So, in terms of natural gas, we looked at the unneeded, the unneeded, and remember the unneeded is always higher cost. So we've called this high cost, high carbon. And we've looked at that by country and types of production. And the types of production will be LNG, they will be conventional pipe gas, and there will be tight gas. And we've looked at them in terms of Europe and North America, with the LNG market being the global market. And therefore, again, we've seen what lies above our low demand scenario, and for reference, what lies above the actual carbon budget itself. So The final move is to relate this to the capital expenditure required to deliver this potential production over a 10-year time frame, in this case, between 2015 and 2025. And then we want to tie that to companies directly. We believe a 10-year time frame does make sense for a corporate planning cycle. By doing this and tying it to the big companies that may be involved in what we believe are the unneeded projects, we are identifying the potential wasted capital and even what could end up being stranded assets in the future, and tying those directly to specific companies. So we now turn to our team to present the detailed results in terms of demand and supply. However, it is worth noting that in many ways, natural gas is the most complex of the fossil fuels when put in a carbon and climate constrained world. Natural gas does have the ability to deliver lower carbon content than coal in particular. However, it's very important that natural gas be extracted in a very clean and efficient manner in order to deliver that. Also, in the longer run, it's important that natural gas does not become so dominant in the energy system that it would displace renewable and even lower emissions fuel sources, such that in the longer run, a 2-degree world would not emerge.